Hi all, welcome back. So today we are going to solve all the questions from applications of derivative or AOD which came in different shifts of 2025 attempt. In AOD we have total 8 questions out of which 5 are easily doable and 3 are moderate which we are going to solve. This difficulty level is based on my perception which may be different for others. So let's move on to our first question. Before we start solving, here we have analysis of each and every questions with underlying topics, summary and conceptual questions with difficulty level. So hope this will be helpful for you. Here is our first question. Our question says if the function f of x where a is greater than 0 attains its local maximum and local minimum values at p and q respectively such that p square is equal to q, then f of 3 is equal to. To solve this question, first step will be find local maxima and local minima. Second step will be using the relation p square is equal to q. We need to find a. Third step will be find f of 3. Now, first let's take first derivative of f of x, f dash x. And let's also take 6 common, we will get x square, 6 times x square minus 3ax plus 2a square is equal to 0. Now, on solving this quadratic equation, we will get x is equal to a comma 2a, in which one is local minimum and one is local maximum. To verify that, we are going to use second derivative test. F dash dash x is equal to six times 2x minus 3a. Now, f dash dash a is less than 0 because our a is greater than 0. And f dash dash 2a will be greater than 0. F dash dash 2a will be 6a. So, which is greater than 0 because a is greater than 0. From here we can say a is local maximum and 2a is local minimum. Now our p is local maximum and q is local minimum, and p square is equal to q. From here we can say that a square is equal to 2a. From here a is equal to 2. A is equal to 0 will be rejected because a is always greater than 0. So a is equal to 2, then our f of x, wait a minute, our f of x will be equal to f of x will be equal to 2x cube minus 18x square plus 48x plus 1. Now our f of 3 is equal to f of 3 is equal to 27 times 2 will be 4 154 8 sorry 27 yes 27 is 10 2 and 18 times 9 will be 2 7 162 plus 54 will be 8 8 1 2 1 8 and 48 times 3 will be 48 times 3 will be 4 2 12 144. So first let's wait a minute. We have this in minus, sorry. We have minus 162 plus 54 and plus 144. Yes. Now 144 plus 54 will be 198. 198 minus 162 will be 636 and 36 plus 1 will be 37. So f of 3 is equal to 37. So from here, our answer will be option D. And here is our solution, and we can see that our answer is correct. Now here is our second question. This time our question says the shortest distance between these two curves is. Now this is a parabola, this is a circle. So to solve this question, our first step will be find common normal from these both from these both curves, common normal of these two curves. Second step will be find shortest distance. So let's plot a graph to see where our common normal will be plotted. This is our parabola. And here we have our circle. This point is our center, and center according to this equation will be 0, 6. Now we need to make a common normal, and we have property a normal to a circle passes to its center. So let's say this is our common normal. Let's say this is N. This point will be P. This point will be Q. Now first let's find equation of normal to parabola. Then we will make it pass to the center of circle. So for parabola, this will be y equal to mx minus 2am 4m minus a n cube 2m cube. In this case, our a is 2 according to parabola. Now Now L passes through C. L passes through point C. So from here we can say minus 6 is equal to minus 4m minus 2n cube. On evaluating, this will be dividing both sides by 2, taking all the numbers to the left hand side, we will get m cube plus 2m minus 3 is equal to 0. Now we can divide this as m minus 1 and m square plus m minus m square and minus m square, no m square, and plus 3. Minus 1 into 3 will be minus 3. 3m minus m will be 2. Yes. This is equal to 0. Now this quadratic has the discriminant of less than 0. So we have no roots for this quadratic equation. And we will compare minus m minus 1 to 0. We will get n is equal to 1. Our m is equal to 1. So from here, point P will be am square comma, or let's write a is 2, so 2m square comma minus 4m minus 2am will be minus 4m. So from here we will get 2 comma minus 4. Now instead of finding point Q, we can find the shortest distance because this is the radius, and from here shortest distance is equal to distance between point P and point C is C minus the radius. So distance between point P and point C will be under root of 4 plus 4, 8, which is 2 root 2. And radius will be under root of 6 square, 36 minus 35 is equal to 1. So we will get 2 root 2 minus 1. From here our answer is option D. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says that f r to r be a function defined by this. M is number of points of local minima and is number of points of local maxima, then of f, then m plus n is. So here in this question, our f of, first let's write the steps to solve this question. First step will be draw graph. Second step will be find m and n, or number of points of local maxima and minima. Local minima. So our f of x is equal to mod of x plus 2 minus 2 times mod of x whole mod. Now let's find the points where our graph will take a sharp edge. There are the points where the graph will take sharp edge if any one of these 3 mods will be 0. So clearly we have minus 2 and 0. And when these two will open with positive or negative, we will get x plus 2 minus 2x minus x plus 2. So x is equal to 2, and if these two will open alternate, then we will get x plus 2 minus 2, plus 2x we will get 3x plus 2 minus 2 by 3. Now let's plot these points. We will get point, this is 0, this is 2, this is minus 2 by 3, this is minus 2. Now, when x will be greater than 2, both will open as positive. Then we will get mod of minus x plus 2 or mod of x minus 2 like this. And when x will be less than 2, again both will open with positive between 0 and 2. Both will open with positive mod of x minus 2, but this will open with negative. So, like this till 0. And when x is between 0 to minus 2 by 3, this will open with positive and mod of x will open with negative. So, x plus 2 plus 2x, 3x plus 2 with a mod. Now, original graph for 3y is equal to 3x plus 2 will be original graph will be x0 then y2. Original graph of y is equal to 3x plus 2 will be like this. So mod of 3x plus 2 between 0 to minus 2 by 3 will be like this. And again between minus 2 to minus 2 by 3, this will open with positive, this will open with negative. But this mod will open with negative. So here we have one change. So which graph which was going like this will go instead like this. And will stop at minus 2. And when x will be less than minus 2, both of these two will open with negative. So we will get minus x minus 2 plus 2x plus 2x, which will be x minus 2. X will be less than minus 2, so this will open with negative 2 minus x. And when we will put minus 2, we will get point as, please wait a minute. Point will be minus 2 comma 4, and the following graph will be like this. Yes. Now let's find the values for m and n for points for local maxima and local minima. Now m is number of point of local minima. We attain local minima at 2 points. So m is equal to 2. N is the number of points of local maxima which we get only one time. So this is equal to 1. From here our m plus n is equal to 3. So our answer will be option B. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says let a will be greater than 0 if the function f of x attains its local maximum and minimum values at the point x1 and x2 respectively such that x1 x2 is equal to 54, then value for this expression is equal to. So first let's write the steps. First step will be find. This is very similar like the first question. Or am I right? First question. Yes, first question. So find local maxima and local minima. Second step will be using the relation x1 x2 is equal to 54. Find a. And the third step will be after finding a, A, and from A find x1 and x2, or let's write find A. Third step will be find A plus x1 plus x2. Now first we need to find local maxima and local minima. So to find that, our f dash x is equal to f dash x is equal to, we will take 18 common, we will get 18 x square minus 5ax, and we will take 9 out, we will get 1 and 2, so minus 6, sorry, plus 6 a square is equal to 0. Now the roots for this quadratic equation I have taken common in the first derivative to the outside. Now roots for this quadratic equation will be x is equal to 2a comma 3a. Let me check it again. Yes, x is equal to 2a comma 3a. Now we need to find which is local maximum and which is local minimum. So we are going to use the second derivative test again. Our f dash dash x is equal to 18 times 2x minus 5a is equal to, not equal to. Now f dash dash 2a will be minus 18a, and a is greater than 0. So f dash dash 2a is less than 0. F dash dash 3a, this will be 6a minus 5a, 18a, a is greater than 0, so this will be greater than 0. From here, 2a is local maxima and 3a is local minimum. Now our x1 attains local maximum at x1 is 2a, or let's directly write x1 x2 is equal to, x1 x2 is equal to 54. From here 6a square is equal to 54. So from here we will get a is equal to 3. If a is equal to 3, then x1 is local maximum, which is 2 and 6, and x2 will be local minimum. X2 is local minimum, which is at 3a. 3a will be 9. So from here, our a plus x1 plus x2 is equal to 9 plus 9 is 15. From here, our answer will be option B. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says, let f be a differentiable function on R such that f of 2 is equal to 1 and dash 2 is equal to 4. Then this limit, we have this limit is equal to e raised to power alpha. The number of times this curve meets the x-axis. So to solve this question, first we are going to write the steps. First step to solve this is find the value of limit, and second step is on comparing find alpha, or let's write find limit, then alpha. Second step will be make or solve the curve, which is actually cubic equation. When we will put the value of alpha, this will be a cubic equation. Now, so our first step will be to find limit x tends to 0. Now this limit is f of 2 is 1 raised to power infinity form, so we can write it as e raised to power limit x tends to 0 of f of 2 plus x minus 1 into 3 by x. This is equal to e raised to power alpha. Now in the above limit, we are going to be using LH rule. So here we are going to use the LH rule. We will get e, differentiate numerator denominator, so we get limit x tends to 0. Derivative of x is 1, so denominator is 1. Numerator will be 3 f dash 2 plus x, and minus 1, derivative of minus 1 is 0. Now when we will put the 0 inside, we will get 3 times f dash 2. 3 from here, we will get e raised to power 3 times f dash 2. F dash 2 is 4. So e raised to power 12 is equal to e raised to power alpha. From here, alpha is equal to 12. Here we have alpha is equal to 12, so our y will be equal to. Now let's take 4 already common from these terms. We will get x cube minus x square minus 5x and minus 3. Now we can separate this equation as x square plus minus 3 2x square minus 3x square x cube and x minus x. Yes, we can separate this cubic equation like this. So further, this is equal to 0. 4 times x plus 1 whole square into x minus 3 is equal to 0. From here we will get x is equal to minus 1 comma 3. Wait a minute. Yes. So let me recheck. Minus 1 minus 1 minus 1 minus 2. Yes. So from here our answer will be option A. And here is our solution, and we can see that our answer is correct. Now, wait a minute, I need to check one more thing here. Yes. Here is our next question. This time our question says, Let x is equal to -1 and x is equal to 2 be the critical points of the function f of x, and let m and capital M be respectively be the absolute minimum and the absolute maximum values of f in this interval. Then we have to find the value of this expression, and this is not C here, this is E. Here also we don't have C, this is E. Let me check in the second page. Yes, here we have A, B and C. We have no C. We need to find A and B. Now, first let's find f dash x. F dash x is equal to 3x square plus 2ax plus b upon x. Now, f dash of -1 is equal to f dash -1 is equal to 3 plus 2a plus minus b is equal to 0 and f dash 2 is equal to f dash 2 is equal to 12 plus 4a plus b upon 2 is equal to 0. And also from now it's clear. Let me again write the steps to solve this question. First step will be find A and B. Find A and B. Second step will be plot wavy curve. Wavy curve is we plot like this, plus minus plus minus. That is a wavy curve, plus minus plus like this. And the third step will be find capital M and small. Now from this first equation, from the f dash -1 is equal to 0, from here we can say 2a, this is -2, sorry, 2a is equal to 3 minus b. Now we are going to put 2a is equal to 3 minus b in this equation. Then we will get 12 plus 6 minus 2b plus b by 2 is equal to 0. 3 by 2b, 2 by 3 and 2 18, b is equal to 12. B is equal to 12. If b is equal to 12, we will substitute in this equation. We will get a is equal to -9 upon 2. Here we have values for a and b. Let's find f dash x now. Our f dash x now will be -9 by 2 minus 9x plus 12 upon x. This will be, let's take 3 common. We will get x cube minus 3x square plus 4 upon x. Now this equation will have 3 roots. We know the first 2 roots is one is minus one is 2 according to the question. So one root is minus one root is 2. From here, let me check again. Minus 1, minus 3, yes. And for 2 we have 8 minus 12, yes. Now we have these two roots, so here our product of roots is equal to, we have 3 roots for this equation, so product of roots will be equal to minus d upon a minus 4 upon 1 minus 4. From here we have x1, we have x2, let's say this is x1, this is x2. From here we will get x3 is equal to 2. Now we can write f dash x is equal to, f dash x is equal to 3 times x minus 2 whole square x plus 1, x plus 1 divided by x. Now let's plot the wavy curve like that. We will get here minus 1, here 0, here 2. This will be plus. Now we have square at x minus 2 square, so this will be plus again. Sign change minus and again sign change plus. Now, and also I have used the short trick to find the signs, or you can use the standard method, check the value for greater than 2, check value between 0 and 2, and so on. Now the question has given us interval of minus 2 to minus 1 upon 2. So in the question we have this interval. Now this is plus, this is minus, so the point will be like this. So from here at minus 1 we will get our absolute maximum. So our m is equal to f of minus 1, which is equal to minus 1 and minus 1 minus 9 by 2. This will be log of 1 is 0 and the last plus 1. So this is equal to minus 9 by 2 minus, from here our capital M is minus 4.5 and our small m is equal to find small m, absolute minimum, we need to find minimum of f of minus 2 and f of minus 1 upon 2. So first f of minus 2 is equal to, f of minus 2 is equal to minus 8 minus 8 and minus 9 by 2 into 4 minus 18 plus b plus 12 of ln minus 2, 12 ln 2 plus 12 ln 2 plus 1. Now from there we will get minus 25 and ln 2 is 0.7, 12 into 7, 12 into 7 will be 484, 8.4 minus 25 plus 8 will be minus 17, minus 17 plus 0.4 will be 16.6 with a minus sign. 16.6 with a minus sign. Now our f of minus half will be equal to minus 1 upon 8 and minus 9 upon 2 into 1 upon 4, so minus 9 upon 8 minus 12 ln 2 because ln of 1 upon 2 is minus ln 2 and plus 1. This is equal to, we have 8 here. 8. From here we will get minus 5 by 4 plus 1 and minus 12 ln 2. From here minus, this is, we will get whatever this will be. Let's calculate. Point minus 0.25 minus 8.4. So from here we can see that f of minus 2 is less than f of minus 1 upon 2. So from here small m is equal to, small m is equal to minus 16.6. So overall from here we will get mod of capital M plus small m is equal to 21.1. So from here our answer will be option A, and here is our solution and we can see that our answer is correct. Please wait a minute. This is E. Here is our next question. This time our question says let f r to r be a polynomial function of degree 4 having extreme values at x is equal to 4, x is equal to 5. We have this limit is equal to 5. Then f of 2 is equal to, So here in this question, first step will be find C, D and E from limit. C, D and E are the coefficients. We write 4 degree polynomial function as ax4 bx cube cx square dx plus e. So C, D, E are coefficients of x squared, x and y respectively. And second step will be find a comma b from f dash x and from extreme values from, or let's say just find a and b. And third step will be find f of. So here in this question we have limit x tends to 0. F of x is ax4 plus bx cube plus cx square plus dx plus e divided by x square is equal to 5. Now for this limit to exist, d and e should be equal to 0. And then for this limit to be equal to 5, c should be equal to 5. And a and b are still unknown. Now from here our f of x will be ax4. Let's write f dash x. This will be 4ax cube 4ax cube plus 3bx square plus 2cx plus B. We don't have D, we can write 2C as 10x. Now our f dash 4 is equal to from here we are going to take 4 common, then we will get 4 square 16 into 4 64 x 64a 64a and plus 16 into 3 48b plus 10. Plus 10 is equal to 0. From here we will get, let's take 2 also to the right hand side, we will get 32a plus 24b plus 5 is equal to 0. F dash 5 is equal to, this will be, let's take 25 common, you will get 20a plus 3b plus 2 is equal to 0. Now from here let's separate 3b. 3b is equal to minus 20a minus 2. Now let's put this in the above equation. We will get 32a 8, so minus 160 minus 168 and minus 16 plus 5 is equal to 0. So from here we will get a is equal to minus 11 upon 128. Please write down. Here we have 332a plus 24b plus 5 is equal to 0. 3b is equal to minus 20a 3x squared x plus t 0. 8 into 2 160 minus 16. Please write f dash 4 is 16 into 64 40 10. This will be 12, sorry, because we have taken 1 4 outside, we will get 4 into 3 12. This is 12. So from here we will get 32a plus 12 is 4 minus 80a. 12 upon 3 is 4, so minus 80a minus 8 plus 5 is equal to 0. From here we will get 3 upon with negative sign 3 upon 28, 3 upon 20, 532, not 28, sorry, not 28. We will get 3 upon 48. Yes. 3 upon 48, so this will be minus 1 upon 16. So from here, our A is equal to minus 1 upon 16 and B is equal to, from this equation we will get B is equal to 4 upon 4, 5 upon 4 plus 2, 8, 9, 10, 13 upon 4 minus 13 upon 12. So wait a minute, there is one more mistake. Sorry. On cancelling with 2, this will be 6. Sorry for the mistake again. This will be, let's do it fast. 3 to 40 and minus 3 minus 4. From here we will get A as minus or plus 1 upon 8. A is equal to 1 upon 8. Then our B will be equal to upon 2, 5 upon 2 plus 2, 4, 9 upon 2. B will be minus 9, minus 3 upon 2. Let me check once more. 4, 5, 4, 2, yes. Sorry for the calculation mistake in this step. So from here, our f dash 2, or no, we need to find f of 2. F of 2 will be 1 upon 8 into 2 raised to power 4 minus 3 upon 2 into 2 raised to power 3 plus 5 into 2 raised to power 2. From here, this will cancel this 2 times. 8 is 2 cubed. We can write this as 2 cubed. 2 times. We will get 2 minus 12 plus 20. 2 minus 12 plus 20. Our f of 2 is equal to 10. So from here, our f of 2 is equal to 10. So our answer will be option B. And I'm very sorry for the calculation mistake in this step. And here is our solution, and we can see that our answer is correct. Here is our next question. This is an easy question, and this is also the last question. Let the function f of x be strictly increasing in this interval, strictly decreasing in this interval. Then we have to find the value for this expression. So in this question, first step will be find f of x. Second step will be plot wavy curve. Again, as wavy curve is curve for sign change. first step will be find alpha i's. So here our f dash x will be equal to 1 upon 3 minus 3 upon x square. From here we will get this is equal to x square or this will be x square minus 9. We can write x plus 3 x minus 3 upon 3x square. On plotting this, we will get minus 3 plus 3 minus 3 plus 3 between 0 plus minus minus plus. So this curve, we have open interval at this, closed at these two. So in this curve, our f dash x is greater than 0, or where the sign is positive, is the points where the function is strictly increasing. Where the signs are negative, then it's strictly decreasing. And also I use the shortcut to find the sign change. To verify, you can also put the each value, like the values for forward 3, between 0 and 3, and so on. So from here, our for strictly increasing, our x will belong to minus infinity to minus 3 union 3 to infinity, and for strictly decreasing, our x will belong to minus 3 to 0 union 0 to 3. So from here, according to the question, our sigma I is equal to 1 to 5, alpha I square will be equal to 9 plus 9 plus 9 plus 0 plus 9. This is equal to 9 times 4, 36. From here, our answer will be option D. And here is our solution, and we can see that our answer is correct. So hope you found this video helpful. Thank you for watching.